Good morning, all of you. Today we will see the next colligative property, that is osmotic pressure. Before that, let's see what is osmosis. You know, raw mangoes shrivel when kept in saline water. Raw mangoes, raw mangoes shrivel when kept in salt water. Yeah, in brine. Brine means salt solution. Wilted flowers revive when placed in fresh water. Wilted flowers revive when kept in fresh water. Blood cells collapse when kept in saline water. Blood cells means these veins, the blood cells collapse when kept in saline water. What are the reasons behind this? Raw mangoes shrivel when kept in brine. Brine means very highly salt water. These things, this raw mangoes, yeah, wilted flowers, or these blood cells, they have a semi-permeable membrane covering them. A semi-permeable membrane. In chemistry, we call it as SPM, semi-permeable membrane. When raw mangoes kept in brine means what happens since these raw mangoes are covered by raw mangoes have that semi-permeable membrane. What is the speciality of the semi-permeable membrane? It allows the flow of only the solvent, not the solute particle. It allows the semi-permeable membrane allows the flow of solvent. Now what happens? The solvent flows from lower concentration to higher concentration. Solvent flows from lower concentration to higher concentration. Brine having higher concentration of salt. Brine having higher concentration of salt. What will happen? From mango, water flows, the solvent flows through the semi-permeable membrane to the brine. Now, wilted flowers, when kept in fresh water, what happens? From lower concentration, from lower concentration, this water flows to the wilted flower. So it revives. What, what about blood cells? Blood cells, they collapse. Means from blood cells, from this RBC, water content flows through the semi-permeable membrane to the saline solution. So our blood, that is the RBC present, that is having, RBC is having a concentration which is matching to 0.9% W slash V NaCl solution. So if such a solution, if a solution having a concentration same as that of that 0.9% W slash V NaCl solution. W slash V, mass upon volume percentage. A solution which is having the concentration which is matching with this 0.9%, 0.9% NaCl solution, that is having the same osmotic pressure as that of our RBC. If such a solution is injected intravenously to our blood cells, to our veins, no swelling or no collapse near the vein you observe, nothing happens. During we during the during the putting of that trips, sometimes you must have seen around the veins there may be swelling. Why the swelling takes place? Why the swelling takes place? When the water from that medicine enters into our RBC. Then this swells. Otherwise, if that medicine in the trips that is having a higher concentration, what will happen? The, from this RBC, water will be moving out to that medicine. Water will be moving to that medicine. Then the blood cells collapse. So there are two possibilities. If the medicine which is putting inside, if the medicine which is putting inside is having a different concentration as that of that 0.9% W slash V NaCl solution. So the medicine or that solution what is passed through our RBC should have the same osmotic pressure. If that medicine is having a lower concentration, if that solution is having lower concentration, what will happen? From the medicine, the solvent enters, water enters to this RBC. That is lower concentration. This is higher concentration. If that is having lower concentration, means this is having higher concentration. So in that case, water from the lower concentration enters to the higher concentration through the SPM. If that is having higher concentration, now in that case, what happens? Here it swells. Here it swells. This happened with me during the putting of the trips. I saw swelling around this vein. That means that medicine is not having the same osmotic pressure as that of the osmotic pressure of my RBC. That is having lower concentration. From that, water enters to the RBC. So there was swelling. So that solution, what is putting in the trip, that solution should be having the same osmotic pressure as that of our RBC. If that is having lower concentration as compared to this RBC, water from that will be entering to this RBC blood cells. Or if that is having higher concentration, now what will happen? My blood cells will be collapsed. My blood cells will be collapsed and will be died. So the medicine what is putting or that trips, or you can inject during this injection also this happens. So such solutions which are having the same osmotic pressure of the pressure as that of a RBC can be injected intravenously. Otherwise, either swelling or the blood cells will collapse. That is the importance of osmotic pressure. Osmosis. What is osmosis? The flow of solvent from lower concentration to higher concentration. That is called osmosis. This osmosis can be prevented by applying pressure on the solution side. Suppose two vessels are there, they are connected. These vessels are connected. Suppose two vessels are there, these are connected, and in between a semi-permeable membrane is kept. In one vessel, it is higher concentration, and the other vessel it is lower concentration. Now what will happen? From lower concentration, solvent will be flowing through the semi-permeable membrane to the higher concentration. So higher concentration solutions level will become higher and higher and higher as the solvent flows from lower concentration to higher concentration. So here the level of the solution increases. Level of this higher concentration solution increases. You can apply a pressure on the solution side, on the higher concentration side, just to stop the flow of the solvent. Just to stop the flow of the solvent. The amount or the pressure required the pressure required just to stop the flow of solvent. The pressure applied on the solution side, the pressure applied on the solution side just to stop the flow of the solvent. That is called osmotic pressure. Osmotic pressure is denoted by the term pi. Similar to that PV is equal to nRT, here we can use pi V is equal to nRT. Pi V is equal to NBRT, where NB is the number of moles of the solute. NB upon this pi V is equal to NBRT, that V you can take under that NB. So NB upon V, and V is taken, if V is taken in terms of liter, then NB upon V is equal to molarity, capital M. So pi is equal to that capital M, that is the concentration, CRT or MRT. Pi V is equal to NBRT, that V you can take to the other side under that NB. V can be written in terms of liters. If that is in liters, then NB, that is the number of moles upon volume of solution in liters. Number of moles, NB, that is the number of moles of the solute upon volume of the solution in liters, is equal to molarity. So pi is equal to molarity RT. So this is the equation for osmotic pressure. So what is osmotic pressure? The pressure applied on the solution side, means on the higher concentration. You can separate one solution and one solvent. One solution and one solvent. Solvent is having lower concentration as compared to the solution. They are connected by a tube which is containing a semi-permeable membrane, The solvent from the lower concentration will be passing through the semi-permeable membrane to the higher concentration. Accordingly, the level in the higher concentration increases. You can stop this osmosis by applying a pressure higher than the osmotic pressure on the solution side or the higher concentration. That pressure applied just to stop the osmosis, just to stop the process of osmosis, is called osmotic pressure. That can be denoted by pi V is equal to NBRT. Before osmotic pressure, let's go back to that equation of delta TB is equal to KB dot M, and one more, that is delta TF is equal to KF dot M. Now define KB or define KF. KB is the elevation in boiling point when molality is unity. Similarly, Kf is the depression in freezing point when molality is unity. Also, one more equation is there for Kb. Kb is equal to R Ma. Ma is the molar mass of the solvent. T naught B whole square upon 1000 delta vaporization, delta H vaporization, or Kf is equal to R. R is that universal gas constant. R is equal to, Kf is equal to R Ma, again Ma, then T naught F whole square upon 1000. Now here this is fusion. This is fusion, delta H fusion, fusion. And this is for the solvent. This is for the solvent, both. Solvent. This is for the solvent, of course. Solvent. Now let's come to the osmotic pressure. Osmosis and osmotic pressure. Osmosis and osmotic pressure. Raw mangoes, when kept in brine, means semi-permeable membrane. Raw, raw mangoes, this is SPM, means raw mangoes are kept in brine. Brine means high concentration of salt water. What happens? It shrivels. Raw mangoes shrivels. Wilted flour, when placed in fresh water, what happens? It revives. You must have seen a dried, almost dried carrot. Dried carrot, when kept in water, means here I am showing a semi-permeable membrane. Now, what happens after some time? It becomes revived. It becomes revived. Dried gajar, carrot. Wilted flour when kept. So here, water, in the case of carrot, water enters. This is wilted. Wilted. Wilted carrot. Water enters to this dry carrot or wilted carrot and becomes revived. This is revived. This is kept in plain water. Kept in plain water. Fresh water. I can say fresh water. But this is kept in higher concentration when pickled. Raw mangoes pickled. Pickled means kept in brine. High salt water. We say pickled. Raw mangoes shriveled. See, this is shrivels. Raw mangoes shrivel when pickled in brine, when kept in highly salt water or highly by adding more salt. It shrivels. Wilted carrot or wilted flour becomes revived when placed in fresh water. Blood cells collapsed when kept in saline water. When kept in saline water. So here, what we see, the flow of solvent from lower concentration to higher concentration. This is solvent and this is solution. After some time, you will see the level. After some time, you will see the level of the solution will be increasing. Now, what we are doing, we are applying a pressure. We are applying a pressure, that is pi, just to stop the flow of the solvent. Just to stop the flow of the solvent. Actually, from lower concentration, solvent will be flowing to higher concentration. You can take two concentration, this is higher concentration, this is lower concentration, or this is solution, this is solvent. What happens? Solvent from this side will be entering to the solution side. So accordingly, the level here would be rising. But what we are doing to check the amount of osmotic pressure, we are applying a pressure here. We are applying a pressure here just to stop the flow of the solvent, just to stop the flow of the solvent. That pressure is called osmotic pressure. We denote that by pi. Using that equation means pi v is equal to nRT, which is similar to PV is equal to nRT, what we used last year for the ideal solution. So pi v is equal to nRT, or pi v is equal to NBRT. NBRT. Pi is equal to NB upon VRT. When V is kept in liters, volume of the solution in liters, then pi is equal to CRT, concentration. Pi is equal to CRT. We can say osmotic pressure is equal to molarity into RT. Molarity into RT. Again, this can be utilized to find out the molar mass of the solute. Molar mass of the solute MB, that is NB here from this NB. What is NB? WB upon MB. So using this equation, you can find out the molar mass of the solute MB. This method of determining MB of unknown solute, unknown substance, unknown solute is very useful because there are many reasons for that. The pressure measurement is at room temperature. Pressure measurement is at room temperature. Molarity is an easy preparation. As compared to the other colligative properties, its magnitude is larger. Biomolecules, for example proteins, biomolecules are not stable at higher temperature. If it is elevation in boiling point, you have to reach to the boiling temperature. If it is depression in freezing point, you have to go down to lower temperature. But osmotic pressure is measured at room temperature. So biomolecules are not stable at higher temperature. Polymers have poor solubility. Polymers have poor solubility. You have to dissolve that solute in that solvent, as in the case of elevation boiling point, depression freezing point. So polymers have poor solubility, so not through BP or FP. And now this method is used to determine the MB of proteins and other macromolecules. So these are the advantages of this osmotic pressure over elevation in boiling point, depression in freezing point, or relative lowering of vapor pressure. Now, what are the advantages? Number one, pressure measurement is at room temperature. Molarity is an easy preparation. As compared to the other colligative properties, its magnitude is larger. Biomolecules are not stable at higher temperature. Polymers have poor solubility. It is used to determine the MB, molar mass of the solute of proteins and other macromolecules. Now, isotonic solution. We'll be using the numericals based on this isotonic solution. Solutions having same osmotic pressure means same concentration. Solutions having same osmotic pressure at a given temperature are called isotonic solution. Suppose two solutions are having same osmotic pressure. Even if they are separated by an SPM, no osmosis will be taking place. No osmosis will be taking place. The fluid inside our blood cell, the fluid inside our blood cell is equivalent to that of 0.9% W slash V NaCl solution. This solution's osmotic pressure is same as that of our RBC, the fluid inside our blood cell. Now, I am showing two conditions. In one case, blood cell, that is RBC, I am showing RBC. If it is less than 0.9% NaCl solution, 0.9% NaCl solution. Now, other case, blood cell greater than, concentration greater than 0.9% NaCl solution. What will happen in the first case? In the first case, this side is having higher concentration. So, solvent from RBC will be moving to this. So, what happens? The blood cells shrinks and collapses. It shrinks and collapses. But on the other side, see, this is having lower concentration. This solution having lower concentration. So from here, the solvent enters here. So what happened? Blood cells swells. So here it is collapsing, here it is swelling. So if a solution is injected, if a solution is getting injected to our blood cell, take care that that solution should be having the same osmotic pressure as that of our blood cell, the fluid inside the blood cell. Solutions having same osmotic pressure, the medicines having the same osmotic pressure, or the solutions having the same osmotic pressure can be injected safely. So it is safe to inject it is safe to inject intravenously. It is safe to inject such solution intravenously. So no swelling, no collapsing, no swelling. No collapsing will be taking place, no swelling will be taking place. So these isotonic solutions can be injected to our blood cells. So isotonic solutions as compared to the fluid inside our blood cell, that is the uh, mark. So we have seen what are isotonic solutions. Solutions having same osmotic pressure are called isotonic solution. Suppose a solution is having higher osmotic pressure as compared to with respect to a dilute solution, then we call it as hypertonic solution. A solution of higher concentration, hypertonic. A solution of lower osmotic pressure as with respect to a more concentrated solution is called hypotonic solution. Hypotonic solution. A solution of higher osmotic pressure or higher concentration with respect to a dilute solution is called hypertonic solution. A solution of lower osmotic pressure with respect to a more concentrated solution is called hypotonic solution. Thank you.